Put yourself in the shoes of a network operator. A customer reports a loss of connectivity, you connect to your router, run a ping, and it fails. Then you check the BGP table and the route for the impacted prefix is gone. But what happened? When was the prefix withdrawn? Is the problem visible from other networks? Which BGP update caused the loss of connectivity? Was it caused by your configuration, maybe by your provider or by another network? Answering these kind of questions requires more than just looking at the current state of one of your router. You need maybe historical BGP data from many routers, including routers outside of your own network. So, hi everybody. I am Thomas. I did my PhD at ETH Zurich, where I worked on BGP and I studied BGP convergence time and how we can make it faster. And I am now building BGP routes.io with my colleague. Some of you may already know me and the project because I have presented it at various conferences such as RIPE, NANOG, and Apricot. And in this video, I will introduce BGP routes.io and explain how BGP data collection platforms like it can help to investigate these kind of routing incidents. So this video is divided into chapters with timestamps in the description. So feel free to jump ahead if you are already familiar with BGP, BGP monitoring, or BGP data collection. So let's get started. Let's start this chapter with a new scenario and imagine now that you are the network operator of a cloud provider which has the autonomous system number 10. So you have a bunch of servers and these servers, they use the IP prefix 1/24 which has been assigned to you. And your goal is to make sure that this prefix and thus your servers are always reachable from everywhere on the internet so your customers are always happy. Your network IS-10 connects to the internet through a trusted provider, IS-20, and your customers, they connect through networks such as IS-30, for instance, and wherever they are, at home, or at work, or traveling, you want them to be able to reach your servers. IS-10 uses BGP to tell IS-20, I can reach 1/24, you can send me traffic for that prefix. That's basically what BGP does. IS-20 learns the route and propagates it across its own network. And IS-20 then announces the route to IS-30. IS-30 can now send customer traffic through IS-20 to the servers in IS-10 once it has received this information. The challenge is that these networks are operated independently. The team running IS-10 does not control the routers in IS-20 or IS-30 and vice versa. Inside IS-10, monitoring is easier because its operators control the routing and have access to their own data. So if you are the operator, you can just go on your router, check its logs, check the data yourself and make some decisions. But outside IS-10, things are more difficult. IS-20 or IS-30 can change the routing policy, propagate the route differently, use another path, or withdraw a prefix as well. And IS-10 cannot prevent these decisions. It can only observe the BGP information it receives and react to it. Fortunately, operators from different networks do sometimes meet. For instance, they can meet at conferences such as NANOG or RIPE or Apricot, so they can chat together and take some decisions together like peering decisions, for instance. There are also mailing lists where operators can report some events, for instance, some misconfigurations, but generally speaking, interdomain routing monitoring still remains quite challenging. And it remains quite challenging because in the reality, the internet is just not made of fully autonomous systems, but there are many, many more networks. The internet today consists of tens of thousands of autonomous systems, each originating and propagating possibly many prefixes. And that's why even large companies whose business heavily depends on internet connectivity can experience downtime because of routing issues triggered outside their own networks. The good news is that many networks provide what is usually called a looking glass. It gives you a read-only visibility into the current state of a BGP router, almost as if you had access to the CLI of the router. So you can run commands such as show IP BGP, or you can perform a ping if you want. Here, for instance, is one example from Internet 2. The Internet 2 looking glass is available at console.internet2.edu, and on the homepage, we can see the topology of its US network, including where its routers are located and how they are interconnected. And when we open the looking glass page here, we can then select a router on the left side. And then on the right side, we see the available commands that we can run into this router that we select. And these are the very typical commands from a router CLI. So it's a very complete interface that we have here. Actually, this Internet 2 looking glass is, I believe, one of the best looking glass that I know. And now let's try it out. So for instance, we can run show vrf all. And then run the command, and that will list the virtual routing and forwarding instances on the selected router. We can then run, for instance, show BGP VRF blended, because that's the name of one of their VRF for IPv4 unicast, and let's take 130.79.0.0/16. That's the prefix of the University of Strasbourg, by the way. And then we can inspect the BGP route that this router has towards that prefix in the blended VRF. For instance, here we can see that the AS path to reach the prefix from the selected router is 2965, 2200, and 2259. Looking glasses are useful, but they have limitations. Many networks do not provide a looking glass, and those that do may offer only a limited set of commands. For instance, maybe you may not be able to run a ping, or you just may not be able to run a show IP BGP on some looking glasses. Besides, they are also usually browser-based without like programmatic access, and they allow only one query at a time most of the time. They also only show the current state in the BGP router, so there is no historical data. So basically, to summarize, looking glasses, they work well for investigating a localized event in real time, but for large incidents or for deeper and historical analysis, they are not enough. Aside from BGP looking glasses, there is another approach, which is to collect data with a BGP data collection platform. These platforms establish BGP sessions with real routers for which operators volunteer to share their routing data. For instance, if we take our previous scenario, we can now imagine that IS 10, 20, and 30, they agree to connect their routers to such a BGP data collection platform and export their BGP routes. So the BGP data collection platform collects these routes and updates and store them into a database, and most of these platforms then provide access to this data for analysis, and some also offer browser-based dashboards that help users quickly identify insights and trends into the data. And this is very useful. For instance, network operators in IS 10, 20, or 30 now have access to this data and can use it for large-scale analysis and debugging of real-time but also past routing events. There are many BGP data collection platforms that exist, and probably the most popular ones are Rypress and RadViews because these two platforms exist for decades. So if you can go on their website and you can see all the networks that peer with these platforms. And today, for instance, they each are connected with about 1,500 BGP routers. There are other BGP data collection platforms that exist, such as PCH and CGTF. But recently, with my colleague, we decided to build a new BGP data collection platform that is called BGP Routes.io, and that I'm going to present in the next chapter. To start with BGP Routes.io, let's just open the browser and go on the website. When we land on the web page, we can see various information, including, for instance, here in green, the 4 main capabilities that make this platform very unique. And the first one is that all the data we collect is publicly available and is accessible through an API. And this is important to us because we want to make sure everyone can access the data, including operators, but also researchers and students. The second capability is that everyone can contribute data. It doesn't matter if you operate a hobby network, an IXP, or a CDN, everyone can contribute data. Then we combine the data not just from our own peers, but also we take the data from RIS, RadViews, and we aggregate everything together. And thanks to this, it increases, for instance, the accuracy of our dashboards because we just have more data. And finally, we also support BMP, which is the BGP Monitoring protocol, and that's a pretty cool feature that we will explain in another video. BGP Routes.io also provide several dashboards. You can find the list on the right here. So for instance, the IS Explorer provides detailed information about a given autonomous system, including, for instance, the prefixes that it originates and its relationship with other networks. And the Prefix Explorer here instead focuses more on a specific IP prefix. So it shows, for instance, how the prefix is currently visible in BGP and how that visibility has evolved over the past few hours. You can also access these dashboards from the search bar. So if you enter an ISN or an IP prefix, then you will be directed to the corresponding dashboard. Now, where does BGP Routes.io stand today? Well, it's also visible on the web page. Here we can see that today, for instance, at the time we record this video, BGP Routes.io gets data from about 47 BMP sessions and 114 BGP sessions. And when we combine the data received from these sessions with the data from Rypress and RadViews, then it makes a total of about 4,600 Vantage points. So now in the rest of this video, I will explain you how you can explore this data using the Vantage Points Explorer, and also how, if you're interested, you can contribute data to BGP Routes.io. The Vantage Point Explorer shows all the routers and networks that contribute data to the platform. From there, you can inspect the details of each of these sessions, and you can also really see the raw data that they export. So let's get started, and let's open our browser and go to vpexplorer.bgproutes.io. On the left, you will see a table listing the networks that contribute data either directly to BGP Routes.io or through Rypress and RadViews. There are many networks from countries all around the world. Some of the larger networks connect several routers rather than just one, and the number in the rightmost column shows how many routers each network contributes. This view shows only the traditional BGP sessions. If you click the BMP Sessions tab on the top here, you can also explore the sessions that contribute data through BMP, but in this video, we will just focus on BGP. We will talk about BMP in a following video. At the time of recording, the Explorer contains about 3,300 BGP sessions, And here you can see both the total and how these sessions are distributed across BGP Rust.io, Rypris, and RoadViews. If you click a network in the table, a new tab opens and lists all the BGP sessions contributed by that network. Let's, for instance, select OVH Cloud, which is IS 16276. Here, we can see all the OVH Cloud sessions available through the platform. Some of them, near the bottom of the list, come from RoadViews. OVH also has several BGP sessions connected directly to BGP Rust.io. For each session, we can see its IP address and the size of its IPv4 and v6 ribs. In other words, the number of routes it currently shares with the collector. On the right, we can also see its recent routing activity. This is the number of BGP announcements and withdrawals received from that session during the past 2 hours. We can now click an individual session to inspect it more in detail. A new panel opens on the right side of the screen. Here we can look at, again, the routing activity, but over a longer time period. For instance, we can load the last 12 hours of routing activity. We can also see the session's status over time. This is important to see this information because a BGP session may occasionally go down. This session, for instance, restarted recently, but it did not experience any meaningful downtime. But I think there is another session, maybe this one here, that actually was down. Yes, we can see here, was down for several hours a few days ago. So keeping track of this status history is actually important when analyzing BGP data, because when we observe no routes or no updates during a time period, we need to know if it's because there was just no routing activity or because the session was just down. That makes a big difference. The panel can also display metadata supplied by the operator. This particular session, for instance, does not include any, but when operators connect a session directly to BGP Rust.io, they can attach information such as the router's location or the routing software it uses. Finally, there are 3 ways to access the raw data collected from these sessions, and that's probably what matters the most for you if you want to use the data. So here there are 3 ways you can actually access the data. The first is through MRT files. MRT is a standard format for sharing BGP data. But downloading and processing MRT files can be slow and sometimes challenging. So this is why there is also the API here, and it makes querying the data much easier and faster. And we will see this in a following video. But the third, and probably the most convenient one, at least for a quick inspection of the data, is just to click on this button. And then a new page opens where we can explore the raw data from the selected session directly in the browser. So here we can view either the BGP updates exported by that session or its routing information base, its RIB, at a given time. For instance, we can see updates received from the session only a few seconds ago, so almost in real time. And we can also apply some filters to isolate the part of the data that matters for us. For instance, if I enter here 174, which is an IS number, in the IS pass filter, only routes whose IS pass contains this IS number are returned and displayed here. So yes, here they are, for instance. So you see that it's pretty quick, so it makes analysis pretty smooth. And the same principle applies to the RIB. So what is particularly useful here is that we can inspect not only the RIB in real time, but also we can look at its state at any point in time during the past few weeks. So for instance, here I can select, let's say, August 10 at 10 a.m. And the Explorer then loads the RIB as it appeared at that precise time. And again, the result is pretty quickly displayed. So it makes analysis really like smooth. Everything I've shown you so far is possible because there are network operators that volunteer to connect and share data with BGP data collection platforms. And convincing operators to volunteer is actually one of the hardest challenge when operating such a platform, because the benefit is enormous for the community, but for the operator that share the data, the benefit is less obvious. Think of it as navigation applications that probably you use often while driving. So when someone reports something, a problem on the road or traffic congestion, it's not really beneficial for that person directly, but it's extremely useful for all the people driving behind that person. And in BGP, it's a little bit the same story. When an operator shares data, it's especially useful for the community, for researchers, and for all the other operators. But the good news with BGP is that it can still be useful for an operator to share data, because first, that operator can see the data that it shares, and that can be useful. It's like a looking glass, and some operators, they like this. And second, it also makes our dashboards more accurate, because we can make more accurate inferences. For instance, when we infer the relationship of a given autonomous system, we will make more accurate inferences if that AES actually shares data. Okay, so if I have convinced you now that contributing data can be useful for you and for the community, now I will show you how you can actually do that with BGP routes.io. And I will show you that the process is extremely simple and is fully automated. So now let's go on the browser and let's open the Personal Explorer available at personal.bgproutes.io, and let's see how you can contribute data. The first step is to authenticate. You can create an account or use one of the supported OAuth providers. But to contribute routing data, you need to sign it through PeeringDB, because PeeringDB tells us which autonomous systems are associated with your account, and we use this information to make sure you can create sessions only for ISCs you are authorized to operate. So let's sign in with PeeringDB, and I will use my personal account, enter my password, and then enter the passcode PeeringDB sends by email. Okay, I am now authenticated. On the left, the sidebar gives us access to several operations, including add a new session. So let's click on that button. But unfortunately, my personal PeeringDB account is not associated with an AES. So I cannot create a session, and this is expected. This is why it's written here in red. You can still use the Personal Explorer to create and manage API keys for the BGP Routes API. This is useful to actually get the data, but we will cover this in another video. But basically here, without an associated AES, you cannot register a BGP or a BMP session. So I will now switch to an authorized account in our test environment so I can show you how to add a session. I am now using an account in our test environment that is associated with 3 networks: OVH Cloud, NTT, and Internet2. You can see them at the top of the sidebar. OVH is currently selected. The overview page brings together useful information about the selected AES. We can see its customers, providers, and peers, whether its provider relationships appear in ASPA objects, the prefixes it originates as well, and how many of those prefixes are valid according to RPKI route origin validation and the IRR. There are other information available below, such as the size of the customer account, the RPKI objects created by that IS, but I let you investigate all of this. For now, let's click on add a new session, because this is what matters in this video. And then we select BGP here, because we will cover BNP in a separate video. And then you will see the process is extremely simple. First, here we select the collector that we want to use, and we recommend just choosing the one that is geographically closest to your router because it gives more accurate timestamps. For instance, let's take the one from Düsseldorf here. Then you need to enter your router's IP address, and for this demonstration, we will just choose 1.1.1.1. This is just a test IP. Then you need to enter the ASN that you will configure on your router for this BGP session, and it can be a public or a private ASN. It doesn't really matter because this is just a monitoring session, but it needs to match what you actually configured on your router. Finally, just click on the Submit Session button, and it should be pretty fast. Yes, it's already done. The session is now configured on the BGP Routes.io side. The next step is to configure your router now. So the page below provides examples for several router vendors. It's actually pretty simple. It's just configuring a BGP sessions, but we just need to make sure that the session is configured with multi-hop because this will be in fact a remote BGP session. We also recommend applying an inbound policy that rejects everything. Even though we will not announce everything, this can be just an additional safety measure. Once your router is configured, then click on the Your Sessions button in the sidebar and open the BGP Sessions view, because again, BMP will be for another video. Here we can see the different BGP sessions that OVH has established with BGP Routes.io. We actually don't see the session we just created, the one with IP 1.1.1.1, because this is just a test environment. But here are a few sessions that I've created before, and these ones you can see they're actually up because they are green here. For each one, the dashboard shows its IP address and its routing activity over time. And there are several things you can do on the right side. So for instance, you can click on that button to see the logs of that session. So basically it tells if that session was up or down and during which time frame. And with the update metadata button, you can actually attach some information to your sessions, such as which router software you are using or what is its actual geographic location. And this is public information that then everyone can use for their analysis. So finally, what you can also do is just delete the session. So if you press that button here, it will just delete the session and all the data that was collected from that session. That ends this video. I hope that you find it useful and that it helped you to understand better how you can monitor BGP and how you can leverage this BGP data collection platform. So if you have any question, you can always contact us at this address just here. And otherwise, I would be very happy to talk to you again in a following video, because there are still many things we need to cover and we will do this in following videos. Goodbye.